Hello class, for second and third and fourth periods, I'm sorry there's been a change of plans. Since sixth period will not have any class, well, any class in class on Friday, and all of you guys will have a shortened period. We are moving it to Thursday. So instead of working on SDLs, we are going to go straight to the review and then finish SDLs on that Friday. So for your practice test on forces, if you didn't grab it, here is your practice test. This is the first page. These two problems are exact, well, one of them is on your test. So I would write explanations for both of them. Both of them are about the same, explaining the forces, explaining how Newton's law could help you explain it, and a logical argument as to why someone disagreed with you and what would be wrong with their argument. So what might someone else say and why would they be wrong? Down here, this is all just vocabulary. Now all of these are on there, but you will need to know many of them. Some of the exact answers are in, questions are in there, but they're hidden among everything else. So go ahead, try it. I will spend some time talking about it, and then I'll flip to the next page. So hopefully you paused and tried them. I'm not going to write a lot because we will talk about it in class, but talking about an airplane, so if we talk about, we're going to draw velocity vectors. So talking about its velocity, your ball that is dropped is going quite fast in this direction. It's part of the plane. So as far as velocity goes, you start out going this fast. This is your initial velocity. But then, as time goes on, right, oh, well, after you drop it, we now have gravity. So we still have this velocity vector, but we also have this added tiny velocity when it just fell. But as time goes on, your initial forward velocity will get slightly smaller, air resistance, but overall, the velocity that's changing is your down, because as you fall faster and faster and faster, which, if you look at it, kind of gives us this curved line, because you'll get faster and faster and be going slow, but you will not be changing speed in the constant. So you'll end up here, because this is constant, but you will be falling faster and faster. So the answer would be D. To talk about this, you'd probably have to use Newton's first law, which is the object in motion stays in motion, to explain your initial velocity. Or it doesn't change unless acted upon by an outside source, which would be your Earth acting upon it, making it accelerate in the downward direction. So that would be, and some people might pick A because they think, oh, but the plane's going past it. Sure, the plane's going past it. We don't care about the view from the plane. B would be wrong because it will move forward. It does have some initial velocity going in the X directions. It won't just go just in the Y. So you will need to write an explanation about that. Clearing this. From here, if all the people went to the same place and jumped up and down at the same time, could they knock the Earth out of its orbit? Assume that they can coordinate and jump as many times as you want without getting tired. So what forces would be involved? Obviously the force of people jumping would be involved. It's in orbit, so we do care about the sun's gravitational pull. And we are accelerating because of Earth, so we care about Earth's gravitational pull. So logically, no, right? All of our pounding, exploding, and I think maybe a huge asteroid could knock it out, but it'd have to be huge. And by huge, I mean a lot of mass. You'd probably want to use Newton's second law, or F equals ma, because people have a tiny mass. So the force may be equal, but if our mass is really low, that means, and since we're on Earth, we would have the same acceleration. This must be a tiny force. But and this kind of is high, we're accelerating a lot. But to keep that same low force, we're going to have a huge mass on Earth, like huge. Biggest error I can make without going off the screen. A huge mass, which means that this is really high, but we're going to have, person jumping, not a huge amount of force. That means the acceleration, or its change in where it's going, is going to be ridiculously small, as in nothing will actually happen. Logical argument, that's why someone would disagree with you, probably they'd have to say something, but, all of those people have a lot of mass, but really, even if you get, say, 1 billion people, we do not weigh nearly, or don't have as much mass as the Earth does. Clearing all this. So I'm going to also move pages, because I'm not going to talk about vocabulary in this video. So we're going to add the second page. So this page should look a lot like what we did today. This is those force pairs, where like FN would be the book pushes on the table pushes on the book kind of thing. So I want you to do those for 3 because those will be on the test, so practice them. Adding vectors is what we did today, so draw your vectors, however they go, find your resultant. So all those things I did in the X and Y, this is your X, this is your Y. Describe it so it's going to the left, north, blah, 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 in this direction. Total it, and find your magnitude and your angle, also known as your resultant vector. It includes both the angle and the magnitude or size. So that'd be Pythagorean's theorem and tangent inverse. Moving on to do the next page, clearing everything. So if you are doing this, you want to go back and see all of the different pages and try. So this is the final page. There's not a lot. It's kind of a shorter page. So this is finding the resultant from the last one, Hooke's law, and explain what it is. This would be one-dimensional with springs. This would be two-dimensional with both friction and, so F of F and F of T. So this is definitely a harder problem. I do want you to try it. At least draw the free body diagrams. This is an easier problem. You would have to be able to do this problem to do well on the test. We will continue talking about this tomorrow, but definitely try all of them, especially the first 2 pages. So if you do not get to the second, you're like, but I've been doing this for 20 minutes, stop, you're done. I will see you tomorrow. Make sure you write it down, though, so I can tell that you have done your work. And you will grab the actual physical copy if you have not already tomorrow in class.